perform some problem statements and we will implement it. Okay, so see guys, we know that columns will be of two types, right? Okay, I want to let you know some terminology here. This is very, very important for us from the future prospects. Okay, let's take it. This is my okay. This is my, we know that this is my data set. This is my data set. We know it very well. Data set will be having columns and okay, data set will be having columns and rows, right? Now in the column wise, we are having 1 column, 2 column, 3, 4 and 5. 5 columns are there with us, right? Now this last column, now we know that these columns will be of two types. One is a dependent column, next one is an independent column. I will take this one as a dependent. This is what is called as dependent column. Now the fifth one. Now remaining all, whatever is there over here, this is called as independent columns. Here this is called as independent columns. This is a dependent column, independent. See, we know that the dependent column, independent columns are related to dependent independent column. Okay, independent columns are okay. Now, if there is an independent column and dependent column, now dependent columns are completely dependent on the independent columns. We know that. We know it. I told you earlier also, like this. The example I will say it as, you will take some apartment price, area, location, floor, and area, location, floor, and I can say it as like area, location, floor, and age of the apartment, area, that is how much area it is built, flat, location, which prime location the apartment is there, floor, which floor the apartment is placed, the flat is placed, the age, and the price. Now in this, the price is a dependent. Price is dependent. Column. Okay. Now these all are independent. See, these all are independent columns. Okay, these all are completely independent columns which are not related to each other. Now area and location, it is not connected, or area and the floor is not connected, area and the age is not connected. So they are all independent. These four are independent, but these four will help us to say what is the price. What is the price? Okay, this is the dependent column. This is what is called as dependent, and this is the independent. Okay, now this relationship, we know that there is a relationship. If you change this, the price will change. any of them. If you change this for any of them, the price will change. But if you change the area, the location get changed? No. If the change the area, floor will get changed? No. Change the area, age will get changed? Age, how long it is? No. They all are independent. But if you change any of them, that will change the price. Okay? That will change the price. This is called as, okay, this part is called as dependent, and this is, so we know that there is some relationship between this. We know it. What is that relationship? Is called as regression analysis. There is a term called as regression problem statement, guys. What is the regression problem statement means? Whenever the output column is continuous numerical value or data is considered as a regression problem statement. What is regression analysis? The understanding the relationship between independent and dependent column is called as regression analysis. Okay, regression analysis. Try to understand this. Okay, so and we call it as regression analysis. What is regression analysis? It is a technique through which, or it is a mechanism through which we are estimating the relation. We are finding the relationship between independent and dependent columns, where dependent column is continuous numerical value. Okay, that is what is called as regression analysis. Estimating relationship between independent and dependent columns, or it is a technique through, or it is a mechanism, technique through which estimating relationship between independent and dependent columns, okay, it is a technique through which estimating relationship between independent and dependent column, in which dependent column, or we can say dependent column, is continuous numerical value. That is nothing but a floor. Or it is a technique through which estimating relationship between independent and dependent column, in which dependent column is continuous numerical value. This is called as regression analysis. Okay. Now understand this. Okay, we will do it something like this. See, if there is a, this is my graph. Let's take it. Okay. Now this graph has two sides, right? We call this one as x-axis. This is y-axis. This is x-axis and this is y-axis. Okay. Now, this is x-axis means independent columns. This is y-axis means dependent column. Suppose I have some data over here with me over here like this. Like this. There is a data like this. Okay. This is the data. Now, this is your independent columns. Try to understand this. This is your independent and this is your dependent. Okay. Now, you are trying to estimate the relationship between your independent and dependent. You are estimating the relationship between your independent and dependent. So how you are going to estimate it? There are multiple ways are there. We can estimate the relationship or we will find the relationship in multiple ways. But here what we are going to do it is, we will draw a straight line. We will draw a straight line like this and we will try to estimate the relationship. Okay. Now on this I will do one thing. Something else. Okay. Like this. Now, this is a straight line. Straight line. See, try to understand this. It's a very, very important and interview-oriented question. So, regression analysis means you are trying to find the relationship between independent and dependent column, where dependent column is continuous numerical value. Okay, here what I put it, in which dependent column is continuous numerical value. That's fine. Now here we are trying to find the relationship between independent and dependent column by drawing a straight line. Now remember one thing, whenever you are seeing a straight line, you always remember that this is called as linear. Try to understand that this is nothing but linear. Okay? This is linear. So what will happen is, yeah, this is understood as this is linear. So we are finding the relationship between independent and dependent column by drawing a straight line, right? This is nothing but called as linear. So we can say this process as linear regression. What is linear regression? It is a process of estimating relationship between independent and dependent column by drawing a straight line is called linear regression. It is called as linear regression. Okay, it is a process of estimating relationship between independent and dependent column by drawing a straight line is called as linear regression. Okay, now this is called as linear regression. Now the $1,000,000 question is, if you take a straight line, just like you take it as this is a graph. I'm putting a graph. This graph is having a point. Okay, I'm just putting a point over here. Take it as this is a point. Okay, this is a point here. this one. Okay, this is the point. Now try to understand this. Okay, now how many lines you can pass through these points? There can be n number of lines. Now you can see it. A line may go through like this. Sorry. A line may go through like this. Or 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 like this. So there can be infinite number of lines can go through a single point. In the same way, when you take this one, like this point, just copying this. Okay, I'm just putting down this one over here. Here, this one. Okay, now here these are the lines, right? This is a line. We are passing it. But like this, there will be n number of lines. You can draw it. Definitely there will be n number of lines. Like this, you can go through it. Or like you can draw it this one and this one or this one. Like this, n number of lines here. Which one is a line which will estimate us the relationship between them? Which line is the one which estimates the relationship? Okay. Now the question is that it's a valid question. Which line will help us to estimate the relationship? So the line. Now how to identify the line? Line. Okay. The straight line. Straight line. See, how to identify this one is a line which passes through maximum data points. A line which passes through maximum data points and placed very close to other data points is called, okay, the line which is a line which passes through the maximum data points and placed very close to other data points is called as, you know, the straight line which helps us. I can't say this. This is a line which passes through the maximum data points and placed very close to the other data points helps us to estimate relationship between independent and dependent columns. Okay? A line which passes through maximum data points and placed very close to the other data points helps us to estimate relationship between independent and dependent columns. Okay. Dependent. Okay. How to identify the straight line? This is the line, right? This line we also call this line. There should be some name to that one, right? Every time I can't say it is a straight line which passes through this line. We usually call this line as best fit line. Best fit And the best fit line equation is y is equals to mx plus c. Okay. What is the best fit line? Line. A line, a line which helps us to identify or estimate relationship between independent and dependent column is called best fit line, a straight line. This is again not a normal, it is a straight line which helps us to estimate the relationship between dependent and independent columns is called as best fit line. Okay, clear? Now this best fit line equation is y is equals to mx plus c. Fit line equation is y is equals to mx plus c. Now y is nothing but our dependent column, dependent columns, and x is equals to independent columns. Dependent column, it is one column, okay? And independent columns, it can be m is equals to slope, and x is c is equals to y into c. Y into c. This is how our best fit line we will come to. Okay. Tomorrow we are going to equate this one, and we are going to find out how this best fit line will be helping us to estimate or predict the other values. Okay, tomorrow we will take a small dummy data set, and we are going to find out the error matrix also with the equation, that's all thing, and then we will implement it. I will stop it over here, guys. Let's meet tomorrow at the same time to continue with our class.